still doing. Okay, so first thing first, you have to draw a picture clearly to describe the situation. You have a pair of charges. They are equal in magnitude. If you call this one Q, what's this?
Little
Q.
Must be negative Q, right?
Yeah.
Okay. They have a distance. We can call the distance R, right? Therefore, where is the point we want?
What do you mean?
It says bisector, right? This is the middle point.
Yeah.
But somewhere over here, we want the electric field at this location, right? Okay. Well, let me make it a little bit lower. Okay, we want the electric field at this point. All right. Then you just connect them, draw a dashed line. We want the electric field at this point. Okay. First thing first, you need to pick up this point and put it down somewhere else, right? So how many forces? Oh, not forces. I'm sorry. We want field. How many fields acting on this position? This charge produces a field, right? What's the directional field at this location from this? That way. Why? Because you should assume there is a positive test charge here. Both positive, they repel. Therefore, you have one field goes this direction. We call it E positive Q. Okay? And the negative charge also produces a field. What's the direction at this location?
Down towards it.
Down along this line, right? Because if this is positive test charge, they will attract each other. Therefore, you will have another field that goes along this line. We label it as E negative Q. Okay, therefore, how can you find the total field?
There's one more.
One more?
If you have that point
one
as a,
more?
if you have that point as a test point.
That's a position only, no charge on it. Why we put a positive charge here? Because we want to know the direction, right? Then you remove the test charge. There is nothing here, just a location. We want to know how strong the field is at this location. Of course, this field is generated by both charges, right? And the field is a vector. Therefore, you are doing vector addition, right? Therefore, that's the total field. Suppose this position is P, for example. That's the field at position P. Okay? That's the so-called free body diagram. But this time, the rule is not forces, it's fields. Still vectors. All right.
Quick question, just before you go. So the P is just
Position, this location.
So that's what little P stands for. Just
Yes. This EP means the electric field at position P. And that's what we want. Therefore, just do a simple thing, okay? Do not overthink it. We want EP, obviously. EP is a vector sum, EQ plus E negative Q, right? Okay? Here comes a problem. How to calculate EQ, for example, how strong this field is, do we have a formula for that? We have two equations so far. One is Coulomb's law, K Q1 Q2 over R squared. One is E equals F over test charge Q, right? Do we have an equation for electric field produced by a point charge? Not yet. Can you produce it by combining these two?
Yes.
If you substitute F by the whole thing here, you will get something new, right? Therefore, your electric field will equal to K times Q1, Q2 divided by R squared over Q. Now look at this. What do you mean by the Q here in this definition? Test charge, okay. So which one is test charge here? Could be any one of them, right? So for now, for the source is capital Q, the test charge is Q, right? Therefore, what happened?
You put it as P.
Oh, you have to remove this, right? Therefore, you got an equation for electric field generated by a point charge, capital Q. That's the equation you want. Oh, it's very straightforward. This is the electric field produced by point charge, capital Q. Electric field produced by a point charge, capital Q. All right, so if this is the formula we need, therefore here we can do calculations. Okay? Again, I just give you a whole picture. As a vector, no matter the vector is what, you should have something here plus something here, that is the vector, right? That's EQ. And another one would be something like this and something like this. Now, we just need to fill in something into those parentheses. Okay? All right, so if you write this down right here on this picture, what do we need? We need a coordinate system, right? Okay, you see there is a symmetry here. Therefore, obviously, we have a coordinate system like this. This is y, this is x. Right? Okay, I'm supposed to use a different color now to find the components. Therefore, this is x direction, this is the y direction. For EQ, you see, this is the x component, this is the y component, right? Okay, I just make EQ purely red. And to find the components, we need one more thing. This one can be calculated by the new formula, right? If you want to know this, what do you need?
Q.
You need angle, right?
Yeah.
So at least this angle you need to know, or this angle. Either one is fine. Therefore, look at this picture. Do you have angles?
Yeah.
Oh, yes.
Oh, 90, yeah.
Which angle?
Well, we know that the
See, this angle will change. Depends on where the P is on this line, right? If the P is higher, this angle is larger. lower, this is smaller. Therefore, why not just pick up this angle? If you said this is theta, in this triangle, which one is theta? Upper one or lower one? Lower. This is theta, right?
Quick question, what's the arrow on the y-axis standing for?
This one?
Yeah.
That's the x component of this force. Any force have two components.
We're just breaking it into components.
Therefore, this is the x component, this is the y component. The y component equals this in magnitude, right? It's a rectangle. Therefore, you should be able to calculate this one and this one by using the hypotenuse EQ and this angle. Got it? All right. So what's this? If you know this is EQ, this is theta, how long this is? This is the adjacent side of this angle, right?
Cosine.
Yeah.
Cosine. Therefore, you have EQ cosine theta. How about this one? That's EQ times sine theta. Okay, so we got it already. Here is EQ cosine theta. Here is EQ sine theta. Okay. Then we work on this one. I make it blue. Okay, it's easy. Find the x component and the y component. Y is here, y is here. And this one is not convenient for us. Let me just remove it. The EQ cosine theta, we already put it down there. Okay, now we are working on the blue one, the E negative Q. And if this is theta, what's this angle?
What?
You will have to teach us how to make it up.
Can you say it again, please?
What's this angle? If this is theta?
Is it like
30?
yeah, like minus?
30?
No, we do not know the
We don't
number.
know the angle, just
We
theta
can say
or
minus
Yeah,
theta.
it's like minus something.
still theta in magnitude.
They're
Of course, it's
equal.
negative Q, we don't care.
Okay.
Oh.
Just magnitude, okay? Still Q. Therefore, you know hypotenuse, you know this angle, what's this? It's cosine again, right?
Yeah.
Therefore, here you have E negative Q cosine theta. Here you have E negative Q sine theta. Oh, wait a minute. Are you sure about the size of those components? Look at the red one. Are they all positive?
Yes.
Yes. The two red ones, yes. Are the two blue ones all positive?
No.
No.
This is
Positive.
positive. This is
Negative.
negative. Of course, it's going down. Therefore, I still keep this one positive. You put a negative sign here, right? The y component is negative. All right. Keep going. If you have written this down, 95% is completed already. You just need a basic idea. Look at the picture, two vectors, you add them together, that's it. Therefore, each of the vector has two components. You have to separate them that way, put them down. All right, that's one thing. EQ, we need to know what EQ is, what E negative Q is.